Hi folks, Joseph Kursky here with you to map greening potential in lanes. Now, many municipal and regional governments identify riparian zones, abandoned rail lines, alleyways, and other places in cities that could be turned into greener, more livable places. Okay? The city of Melbourne is also interested and has identified and mapped greening potential in its many back lanes and alleyways. These lanes at present are often undesirable and litter strewn. One of them is shown here. We're going to use a spatial technology, set of tools, and some data, spatial data that's online, to examine these lanes. We're going to access the City of Melbourne's spatial data portal, right here, data.melbourne.vic.gov.au. Search on lane to show the laneways with greening potential. You should be on this page. Click on the title, Laneways with Greening Potential, to pull up a map and a data description. Note that you have two types of maps available, Google and Esri. Why do anything further at this point, since you've got a map at your fingertips? Well, think about your goals and purpose for this lesson. If your goal simply is to have the students understand greening and where the potential lanes exist in Melbourne, you could use this Melbourne map right here. As it exists right here. You could totally use this right here. But if your goal is to foster spatial and analytical skills and dig a bit deeper, your goal typically is to bring the data into your own spatial technology tools, such as ArcGIS Online. Let's do that here to illustrate this point and to compare what you can do with your own tools rather than simply using a Melbourne online map. Again, both are valuable in different ways. Click on Export as highlighted above, and then download the shapefile. A shapefile is to a GIS as a doc file is to Word, as a Excel file is to Excel. You see what I mean? It's one of the native format GIS files out there. Thus, it's not a spreadsheet. It's a GIS file, and it's all ready to be mapped. That's a beautiful thing. Save this file to your local device, noting its name and location. Note that it is stored as a zip file. Spatial data is often stored as a compressed format, like a zip file, because they're big data sets. What else can I say? Big data, right? If they're uncompressed, they are often quite large. So oftentimes data producers will zip the file and place it somewhere so that you can download it and it doesn't take hours. Okay? Now you're ready to do the fun part, and that is mapping your greening data. Go to a new tab in your web browser. Access ArcGIS Online, go ahead and sign in, select Map, Add, and add data from File. You know what's coming next, right? You're going to go to your shapefile in a zip format as shown here. Then go ahead and navigate to the location where your file is stored. Import layer to add it to your map. Click on OK once the smart mapping is finished. You'll change this style soon. Remember, smart mapping is the default map that appears. It's a set of techniques actually that are operating behind the scenes, looking at the kind of data that you're wanting to map and sort of guessing at what kind of symbology you want and the attributes that you want to have mapped. Oftentimes these are really quite good, and it saves you a lot of time. Sometimes you want to override it though, and that's fine. You can override. That's what we'll do here. Now, open the table and note that 246 lanes exist as of the time that this data set was accessed by me. Change the base map to the light gray canvas so that you can better visualize the lanes. Set a few bookmarks. You remember how to do that, right? You basically go to bookmarks, you set a few locations so that you'll be able to come back to different sections of the city later on. Go ahead and save your map, spending a few seconds to provide an appropriate title, tags, and a summary. Share the map with your own organization. Note that the steps in this paragraph that I just read are standard procedures. Whenever you're working on spatial technologies, you're going to add data, you're going to change scale, you're going to change symbology or style, examine the table, setting pop-ups and bookmarks, saving and sharing. Those are the core things that you do when you're inside spatial technology. So it's hopefully starting to become familiar to you. You've done this several times in this module already. Also note that you're becoming more familiar with these procedures each time you do them. Now let's seek to understand what we've got. in its greening database, the city has identified 4 types of possible greening responses: forest lanes, farm lanes, park lanes, and vertical gardens. Higher scores as a composite of these 4 greening responses are stored in a field named insol_score. It's kind of hard to say. Insol_score. A higher score indicates a lower potential for adaptation, and a lower score indicates a higher potential for adaptation into a greener, livable space. Here, a low score of 1 is optimal, right? Lower, higher potential. Change the symbology or style to map the field insol_score as graduated color, as shown here. When done, the lighter colors represent the laneways with the greatest potential for greening up. Open the table again. Each row in the table corresponds to 1 lane, right? It's a database. It's tied to a map, so it's a geodatabase. Sort the field insol_score in ascending mode, so you get the lowest at the top. Then click on the record in the table that contains the lowest score, right? This has the highest potential. And then to the right of the table, click on Center on Selection, so you can see where it is in Melbourne. Lastly, label the features on insol_score with a suitable color so that you can more easily identify the scores as shown here. Save your map again. Now you can determine where the highest potential lanes are. You could visit them if you live in the local area and collect field data on them. Does the assessment of your students agree with, say, the assessment of the city as to the potential for greening? You could do further analysis, such as determine how many are within 1 kilometer of a certain park or the Yarra River, or in a neighborhood with a certain number of cafes, or with a median age within a certain range. You will use some of these analytical tools in the next component. If you would like to look at a map where the laneways with greening potential has already been mapped, go ahead and look at this map here. All right, congratulations. What you've done there is you've added some data from a local authority, a local government authority, in this case on greening. Hopefully you're seeing that, gosh, that's what these governments do to plan more sustainable, effective, cost-effective, healthy, happy cities, right? They produce spatial data. They're using GIS to do that. And you, being an instructor, you can tap into that wealth of data by accessing some of these local portals for spatial data. And then you can build a short activity, as we've done here, where the students are looking at the greening potential for these lanes. And maybe they just pick 2 or 3. And they look at those saying, you know, that really doesn't have much potential at all. It's right next to a hugely busy street, and I don't see much potential. The city says it's a number 2. Why is that? And you just kind of grapple with their own assessment versus the city's assessment. And you can also have them look at the lowest, lowest scores, which is the highest potential, right? And say, okay, why do you think these are the top 3? Let's go ahead and visit those. If you can't visit those, hey, if you're living in another part of the world, no worries. Go ahead and go to Google Street View and see if you can actually pull up an image of that particular lane. That's another spatial activity, right? You'll have to figure out exactly where those locations are on 2 different maps, the ArcGIS Online map and the Google map with the Street View. Lots of things you can do here. All right, go out and make some maps, do some analysis, and change the world. Thanks.